Okay, class, as promised, I'd finish up some more examples of using trigonometry to find areas of triangles. And this works beautifully, even if there's a right angle, a right triangle situation, but that really doesn't have to be a consideration. This angle looks pretty close to a right angle. You could approximate that area with 1/2 base times height, but it wouldn't be the right answer. It'd only be an approximation. Maybe pretty good, but we're going to use the sine function. In other words, we can use that area, and we already proved it the other day, how area equals 1/2 base times height becomes area equals to, if you recall, it was 1/2, A being a side, B being a side, and then sine of the included angle. Now, if you look at what the included angle would have to be, if this was side A and this was side B, this would have to be side C. So this would have to be angle C. So sine of C, A, B, C. The whole alphabet's in there. So the secret is I need two sides that include an angle. Once you have that, you're good to go. Now the problem is I just scribbled on this picture just to say A, B. I don't have angle C. So unfortunately, when I say 1/2 AB sine of C, I don't know what A is, that's what I'm looking for, but unfortunately I don't know what angle C is either. I can plug everything in and say A equals to 1/2 5 times 11, but then I go, uh-oh, I don't know the angle C. So now you're having to do the extra work that we learned, probably like the law of sines that we did was fine. Law of sines to find that angle would have been, let's say I'm looking for C, so I say sine, what is it right? Sine of angle C. Oh, well, that kind of, I don't have side C either. So if I go sine of C over C equals sine of A, I'll call, or sine of B, that would be angle B. So sine of 85 degrees over the 11. What's the problem again? I don't have the matching corresponding angle aside. So bummer, I'm gonna have to find a different angle. So let me try to find angle A then, in this case, this angle right here, angle A, because I do have the opposite side. So this didn't work either. So all I have to do, this is what we do. We trial and we say, hey, what do I need? Sine of A over the 5 would be sine of B, which is sine of 85 degrees over the B, which is 11. Let me just put the 11. So I know that sine of A I'm solving it for sine of A. I'm multiplying both sides by 5. 5 sine of 85 degrees over 11. So I'm going to get sine of A equals to some number. And then I have to get the angle out of there. So angle A, the measure of angle A, would be the arc sine or inverse sine of this particular answer. So why don't I go calculate that and come back? And go ahead, you do it first. Make sure your calculator is in degree mode. I got sine of A is 0.4528. And so I do that math. The inverse sine of 0.4528 will be, and this is the measure of angle A, so let me go and calculate that. Measure of angle A is 26.9 degrees. Now you're saying, well, that's not the answer I want. No, but that is that angle right here. And I wanted angle, obviously I needed the angle C. So if I know the three angles in the triangle add up to 180, then 180 minus those two angles that I have now, the angles were 85 plus my 26.9, and that'll give me approximately, well, let me do 180 minus 85 plus, that's 80, 90, it's 100, 111.9. So I'm looking at angle C, the measure of angle C, that's what this is, measure of angle C, so call it C, is approximately 180. That would give me, just did the work, 68.1 degrees, I think. You can tell me if I'm wrong or not. So then I go back to that formula that I had right here, and I'm gonna say area is 1/2 times 55. That's 11 times 5. Sine of 68.1 degrees. And just type that in, and you tell me what the answer is. I'm not going to go back to my calculator. But you type it in, 1/2 times 55 times sine of 68. Now, somebody else could have said, well, why did I do that? I already had, I already got this angle here. I could have done this problem as, since I found that angle to be, it could have saved me some work, 26.9. I could have done the work as area is 1/2 times these two sides, which, well, I didn't have side C. I needed to have side C as well, so I don't know. I think I'm okay. All right, now the last, I'm not going to do this problem. You do number 6. You make sure you get it done. We'll compare our answers. Heron's formula works for any triangle. What it is you have any triangle at all, sides A, B, and C. All we have are sides. And we know that we're going to come up with another variable called S. And I don't know even what it's called. But I know S is equal to 1/2 of the sum of A plus B plus C. So you need to know what S is. It's 1/2 times the sum of the three sides. Heron's formula says area will be the square root of S times S minus one of the sides, A, times S minus the other side, B, times S minus the other side, C, where S is 1/2 times the A plus B plus C. But you really need to find out what S is first, so you can plug it in 4 different times. We have A, B, and C in our problem. So for instance, look at I have 18, 21, and 19. So Heron's formula is actually pretty simple, but it's just, number crunching with a calculator. First, find out what S is. And S is 1/2 times 18 plus 21 plus the 19. That is equal to 1/2 times 20, 30, 40, 49, 50, 58. I think, unless I did it wrong, I always mess up. 1/2 of 58 is 29. S is 29. Doesn't have any unit, okay? It's just 29. It's just this magic number you have to find. This famous Greek mathematician from thousands of years ago discovered this formula. So area will be the square root of 29 times 18 minus 29 times 18 minus 21. What am I doing? Yeah. Wait a minute. Is that going to be the truth? S is 29. I have it backwards. It's 20. It's S minus the side. Duh. Look it. I see it right up here. Not really sure why why I wrote it backwards. It happens. I was thinking something's not going to work out. I'll keep getting negative numbers. 29 minus the 18 times 29 minus the 21 times 29 minus the 19. A is equal to the square root 29 times 29 minus 18. And that's a 1, 11, I think. Yeah. 29 minus 21 is 7, 8, 8. 29 minus 19 is a 10. And so it's approximate now. Use your calculator. Just go to your calculator and, well, you don't even have to write it again. You don't have to write out what that number is. Go ahead and just use your calculator. And don't forget, the last problem I did up here, what did I not do? I didn't use my units, centimeters squared. Oh, I didn't finish it, centimeters squared. I'm sure you would have put centimeters squared. Whatever that answer is, okay? This one's gonna be, I don't know why that black bled like that, like a real marker. Centimeters squared, again, or yeah, centimeter, no, I'm down here. Miles, square miles. So go ahead and do your calculator. Square root of 29 times 11 times 8 times 10. And double check your work. 159.7, if I remember right. 159.7 square, oh, that was weird, square miles. That's Heron's formula. I'll just set number 8 up. Triangular piece of glass, have side lengths that measure 35 inches, 27 inches, and 14 inches. Doesn't matter what the picture looks like. You just got 3 sides, 3 different angles, and find the area of the glass to the nearest square inch. So S will be 1/2 of 14 plus 35 plus 27, which is 1/2 times 30, 40, 50, 60, 67, 72, 76. That's 38. So area will be the square root of 38 times 38 minus 14. If I do that in my head, let's see, 24. Oh, yeah. Then 38 minus 35 is 3. Then 38 minus 27. 38 minus 27 is 11, I think. 11 plus 20, yeah. So put that in your calculator and give me your units of inches squared. All right? Well, that's it. I did promise to do a couple more problems and send you. So I did one more of using the 1/2 AB sine of theta, and now you've got a couple Heron's formula. Adios.